then, so just quickly, we're going to have a look at byte strings, and you can really see the difference between how unpacking affects byte strings. I'll quote, we can view data of a byte string. What's a good? There. Okay, and so the byte string is it's an offset in a length to a chunk of foreign memory. That's
so it's not drawing the.
It doesn't step into that byte string.
Sorry. It's not drawing the address, and it's not drawing the.
Right. The address is this.
The visual, the byte array.
Yeah.
Well, that's the foreign point of context.
Yeah, this is the foreign point of context.
Which also points to.
It has two guys hanging off it. Yeah. So it stops at one point.
It's not
then we can make a lazy byte string. And a lazy byte string is, remember, it's a lazy spine of strict chunks that are each about the size of the L2 hash. And here, in this case, it's just one chunk, which is, the chunk, so this chunk, which is a strict byte string, has been unpacked into the cons node of the spine of the lazy byte string. So 0 and 3 is referring to the whole thing, but here it's the length of this chunk. And we just have it for the tail. So that shows how the strict byte string was unpacked into the constructor of the lazy byte string, which is what's so that's pretty much the demo. I would just encourage people to play around with this. I think it's really useful when you're designing structures. Nicholas and Christophe are working on data.map during the hackathon that tries to unpack multiple nodes and gives better data density.
If you want to 3D demo.
I don't know Ubigraph. Do you want to quickly demo Ubigraph?
Can you view a cyclic list?
Yeah, we can. Yeah, so we can look at the sequence structures. Yeah. So there's a. Or we can look at like mutually recursive structures. Select one is equal one. Isn't that great? Yeah. So that's why we do functional programming, right?
What does a pair of an empty list and an empty string look like?
A pair of the empty list.
Can you make a lambda string?
And the empty.
Hence the empty string.
Well, yeah. It's a polymorphic
yes.
empty.
So there is indeed only one nil.
There's only one nil. Yeah. Okay. So
I have one issue. I don't have a display. That's a graphic of key values of 10, 10, 1 to 10 for input keys and 1 to 10 for values. And you see, like, for instance, this is key value 8 and value 8, right? And there's a lot of extra pointers which are not required.
So this is in the flat version. This is the map with all the nodes that are hanging down. It's quite a large tree.
And the reason it's a ball is because they all share a div node, which makes it display a bit oddly. And if you go to the adaptive version, you basically get this. And you have your keys and values both stored inside your constructor. And actually, we've been experimenting on flattening it even more, right? Basically, flattening different nodes together, and you get something like this. So this only has 7 or 8 nodes, but it has 10 key value pairs because you basically flatten your to a 3-node system into.
Right. So you get like 10 things unpacked into
Right. So this is size 10. It's top on node, which key value 4.
Yeah. I think
and
that's
it has two children. It has two children, right? So then it's size key value, and it has 4 pointers into the 4 other
So it's all possible combinations of 2 levels.
Yes.
Yeah.
And so GHC, this is really stressing GHC's unboxing capabilities, because I think 10 is the default point at which you have to pass an extra flag. You have to say unpack limit is greater. Yeah. But it's just generating standard code to handle this. So the user level code doesn't know about this crazy representation change. But very
This
cool.
is just like, it's a standard, yeah, one adaptive map implementation, and it just has a different instance defined. It does some reconstruction on views because you have to basically have your left and right node.
Yeah, you can no longer expose the constructors directly. You have to hide the constructors and exploit them as smart constructors.
And these structures.
But we get much greater data density. So I guess the goal would be to benchmark them.
Yeah, it is a benchmark this and this benchmarks based on data map.
And just off the top of your head, what's the footprint of this is like a quarter? But I'm just trying to think about how many nodes we
Well,
removed.
for every pointer you have this tag, 4 byte or 8 byte, depending on
Yeah.
So every time you run box, you say 2 words.
Yeah.
One for the header word of the object that is no longer existing, and one for the pointer.
Right, so you're saving 2 words on your key, 2 words on your value, and then you're basically cutting the keywords for this.
Yeah, so you end up reducing a whole bunch of nodes.
So like for the simple version, you basically go from like 301 bytes to 201 bytes. For this case, I haven't measured how big it is.
So we should be able to get much larger container types in memory, like 3 or 4 times larger just by changing, just by tweaking. Cool. Okay. Thanks everybody. Playing around with vacuum and the container stuff is starting to appear on Hackage. So if people want to benchmark that, that would be really good.